Assalamualaikum warahmatullahi wabarakatuh. My name is Eizzaniq, and I am a final year student of BNT, and I'm going to present to you my final year project, which is soil settlement and tunnel deformation pattern analysis of underground single tunnel MRT Putrajaya Line by using Finite Element Method.
Kuala Lumpur is a big city famous with traffic congestion and pollution problem. So some of people would like suggest to integrate the existing rail network, and MRTC is one of the company who had implement by connecting all the network in KL, such as LRT, monorail, and KTM, and provide a premium quality service at a reasonable fee. So Putrajaya Line is the second line of KVMRT Project after Kajang Line operate. So in PY line alignment, there are underground alignment which travels through Kuala Lumpur Limestone, Granite, and Canny Hills formation. So there have a process of tunnel excavation that will cause disturbance surrounding soil. So as an engineer, the observation of behavior of soil caused by the ground movement is one of the issue. So to predict the ground behavior, finite element method come as a solution in this issue. So I am using the PLAXIS 2D I am using PLAXIS 2D to analyze the soil and tunnel model to see the settlement and tunnel deform. There will be 3 parameters, which is changing the tunnel depth, groundwater level, and soil stiffness, to see the effect to the surface settlement and tunnel deflection. Proceed with the introduction. So the total alignment in Putrajaya Line is 57.7 km with 44.2 km elevated track and 13.5 km underground tunnel. So as I said before, the underground alignment in Putrajaya Line will traverse through Kuala Lumpur Limestone, Granite, and Canny Hills formation. So there will be a lot of excavation that need to be performed in order to complete the project. So there are many factors that cause the disturbance of surrounding soil during the tunnel excavation. So the excessive ground settlement give a major impact to the ground structure. So as a result, finite element method and finite element method or finite element analysis give a best approach in order to solve the issue of ground settlement and deformation tunnel during design phase. So FEA is a mathematical equation used in conjunction with FEM to simulate how the model will react to the real world stress. PLAXIS is one of the finite element program simulate the soil behavior using the soil model. So this software also capable to deal with a lot of complex construction, and it also have a 2D and 3D version. This software have provide a deformation of stability, dynamic, and groundwater flow in geotechnical engineering tools. During design phase, commonly facing some of the issue including complex boundary condition that may change during construction and in elastic material that cause deformation, especially in MRT project. So the aim of this study is to observe the effect of soil settlement change during tunnel excavation, and from the study I will be analyze the ground settlement and deformation pattern of tunnel using finite element method, using PLAXIS 2D software. Finally, I will validate the allowable settlement and tunnel deflection based on standard MRTC standard MRTC, because my scope project is in MRT. Next, for the literature review part, here are some of the findings that I have insert in this project. The first one is from Board Tunnel Design Report by MRT 2017. From the research, I have found that the underground tunnel for PY Line project traverse through Kuala Lumpur Limestone, Granite and Canny Hill Formation. Next, by Selby 2000, in terms of ground movement, tunneling through soil cause ground loss due excavation, which also produce surface settlement and traverse movement. It is important to estimate the effect to the structure when tunnel drive through below the existing structure. From Moon J and Fernandez G 2010, in terms of groundwater level, I found that groundwater level always remain at initial level during tunnel excavation. In order to build a tunnel, groundwater level is always at initial during tunnel excavation. If the excavation was performed below it, it will affect to the facility operation, design, and cost of construction. Next, by Zamani B and Motahari, in terms of soil stiffness, understand how the soil or rock surrounding a tunnel deform is elastically in response to change in stress. If the stress around the opening excavation is not high enough, it will cause the soil or the rock deform elastically at the very least. The final found in Unit 4 settlement, in terms of settlement, the settlement generated by cuts excavation that has the limit the distance equal to the depth of the cut. I understand that if a structure near the excavation project, especially in sandy soil, it will cause damage to the structure and produce more settlement. Next, I will proceed with my methodology of this research. This is the flowchart project from the start to the investigate the effect of deformation pattern of soil based on the previous study, and I will focus with 3 parameters, which is the tunnel depth, groundwater condition, and soil stiffness. And then after the study, I will create soil and tunnel modeling by using the PLAXIS 2D. So all the material properties I've get from the geotechnical interpretive report provided by MRT, and then I will perform a parametric study to see the effect of changing the water level, depth and soil stiffness. So from the modeling, I will get the data analysis of total settlement and tunnel deformation. From the result, I will validate with the acceptable settlement, followed by MRTC guideline and need of statement design criteria. Finally, I will review the influence of groundwater level, tunnel depth and soil stiffness based on the result that I get. So here are the below is the process of the design that I will be implement. First is to define the soil stratigraphy of the model. So the soil stratigraphy I have get from the GI report from MRT, and then I will generate and assign the material data, which is I will insert it in my PLAXIS, and then I will define the tunnel. Also, I have also been provided by the MRT tunnel design report, and then I will mesh the design to get an accurate calculation, and then I will be perform the calculation, which is there will be two phases in this project. The first one is the initial phase, where I have to deactivate the tunnel lining and soil. For the second phase is the volume loss of 1%. I will activate the tunnel lining and deactivate the soil modeling to see the tunnel deform, and then from that I will get the result as an output of this PLAXIS. So as you can see from the poster beside the flowchart, there is my modeling, tunnel modeling and soil modeling. So the actual case of tunnel depth in MRT based on my choosing chainage is 32 meter below ground level. So there will be 4 formation that I will be implement, which is the alluvium, Canny Hill formation with SPTN more than 150, and Canny Hill formation SPTN more than between 65 to 75, and finally the granite. As a result, the parameter of water level, depth and soil stiffness description and assumption during tunnel excavation were investigated. There will be 3 hypotheses expected from this model. The first one is the anticipation of more ground settlement when tunneling close to the surface. The anticipation of tunnel deform when depth is increasing, and the anticipation of decreasing surface settlement when the soil stiffness was increased. So from the data analysis, we will see the graph and the figure of surface settlement and tunnel deformation. The first one is the graph of effect tunnel depth to the surface settlement when at the particular groundwater level and soil stiffness. So the in this case, the depth of the tunnel will be changed from 5 meter, 20 meter, 10 meter and 32 meter. Note that the 32 meter is the actual depth of based on the real case situation in MRT. So from this graph, we can see that the highest settlement produced is the tunnel depth at 5 meter, and the lowest settlement produced is tunnel at the 32 meter below the ground. So from this case, we can see that the tunnel, the settlement produced is decreasing when the tunnel depth is increased. For the tunnel deformation, in case of tunnel changing the tunnel depth, we can see that by increasing the depth, the tunnel shape lining become decrease as the tunnel depth increase. So based on the model result, at the 32 meter depth, the result of the tunnel deflection is 26.73, and based on the design criteria by MRT, the result have exceeded to 25 exceeded from 25 millimeter. So in MRT design criteria have stated that the accepted tunnel lining deflection under load combination must not exceed 25 millimeter on radius. But however, this study is not represent the actual case on site, because there are a lot of consideration that need to be considered but not implemented in this research. Second graph shows you the effect of groundwater level change to the surface settlement at the particular tunnel depth and soil stiffness. There are 4 variable change in groundwater level, which is 5 meter, 10 meter, 20 meter and 30 meter. 5 meter groundwater level is the actual depth in on site based on the report, based on the GI report, and the 32 meter tunnel depth also is the actual depth in GI report. So from the graph, you can see that the settlement produce was increasing. The settlement produce is increasing when the groundwater level is increased. However, based on the result, the distance value between 4 cases is not big, even though the water level have changed 10 meter per each case. In the conclusion, there are changes in the value settlement for the water level, but it does not impact the result. For the tunnel deflection in groundwater level case, it shows that the shape of the tunnel change when the water level depth is increased. The analysis show that when the groundwater level increase or near to the tunnel deform become decreased due to the surrounding force that exerted around the tunnel is decreased. The graph shows you the effect of changing soil stiffness to the surface settlement at the particular tunnel depth and soil and groundwater level. So as you can see, the soil stiffness, the blue line is the original soil stiffness based on the GI report provided by MRT. So when the soil stiffness multiply 2 and 3 from the original, it shows that the settlement becomes decreased from the original. For the tunnel deflection case, in changing the soil stiffness, it shows that there are deflection produced based on the analysis. However, in these 3 cases, the result of deflection are not big. It just different in 1 millimeter each per case. So the analysis shows that by increasing the soil stiffness at the fixed tunnel depth will affect the tunnel lining deformation. However, the same goes to a surface settlement case, the value the value range between the three cases are not big. For the conclusion, by observing the effect of settlement change during tunnel excavation is one of the objectives that have been achieved. From the study, I found that by changing the tunnel depth, groundwater level and soil stiffness will affect to the surface settlement and tunnel deformation. After finding the cause of settlement, I have built a soil modeling and tunnel model using the Finite Element Method to analyze the ground settlement and deformation pattern of soil based on three key parameters. Even so, this study is not represent the actual on-site case where many considerations must be considered, such as the surcharge, soil condition and others. These are some of the references that I have inserted for this project. Thank you.